Hello, welcome to Leetcode. Weekly contest for 26, we are solving a problem. Maximize the number of target nodes after connecting trees, part 1. So in this video, we'll be solving part 1. So the description is there exist two undirected trees with n and m nodes with distinct labels from 0 to n minus 1 and 0 to m minus 1. So typical tree we are given with values ranging from 0 to n minus 1, and n is what is the length of the tree 1 and m is the length of tree 2. Now we are also given 2D integer arrays, edges 1, edges 2 of length n minus 1, n minus 2 respectively, where edges 1 is equal to ai, bi indicates that there is an edge between ai and bi in the first tree, and nodes edges 2 is equal to ui, vi indicating there is an edge between nodes ui and vi in the second tree. So this is basically a discussion given that they will be giving the vector of vector where the first element and second element in every row will be basically an edge between two nodes, that and ui and vi are nodes that they have said. So there's another thing that they have given is node u is the target to node v if number of edges on the path from u to v is less than or equal to k. Note that a node is always target to itself. We need to return an array of integer answer where answer I is the maximum possible number of nodes, the number of nodes target to node I of the first tree if you have to connect one node from the first tree to another in the second tree. Note that the queries are independent of each other. That is, for every query you will remove the added edge before proceeding to the next query. So at first it was very difficult to understand what they are trying to express. So first quickly jump to the example that they have given. So this is the two trees they have given, and what they're trying to say is that it's better we jump on .io. So this is the graph that they have said, and in the first example, sorry, the k is 2. So what they want is that, let us assume we are setting at 0th node. I want that the path that I'm following, that the number of edges that I am traversing, that should be less than equal to k that they have said. So if I going from 0 to 1, the there is uh, assume that this is 1 unit, so 1 unit is being covered. 0 to 2, 1 unit is being covered. 0 to 3, 2 units has been covered, which is still less than equal to k. From 0 to 4, which is again 2, which is less than equal to k. So for 0 we can say that there is 1, 2, 3, 4 and 5, 0 itself, because they have said that yeah, note that a node is always target to itself. So that is why the total possible nodes for the within that same tree, for 0 it is 5. So we have noted down for 0 it is 0, 1, 2, 3, 4. Okay, now we'll go and look for 1. Remember, less than equal to k is the length we need to focus on. So I can traverse to 0 in one unit, then 0 to 2 in traverse in 2 units. But can I go to 3? No, this will take me 3, which is greater than k, so I can't go to 3. So 3 won't be my target path node. Same will be for the 4. So for 1 I can have 0, 1 and 2. So I have noted down 0, 1 and 2. Similarly I will go for 2. So how many nodes can I traverse? I can traverse all the nodes. 0, 3 and 4 are at unit 1 distance and 1 is at unit 2 distance. So for 2 also we can traverse to every possible nodes in the same tree. Similarly for 3 we can only go to, except 1 we can traverse to all, because 4 is at unit 2, 0 is at unit 2 and 2 is at unit 1. So we can have for 3, 0, 2, 3, 4. Same for 4 also, because 1 will be at a distance of 3, which is greater than k. So this first, initially what I did is basically made this at how many possible nodes within the tree 1 I can traverse. That is the one thing that's it. So part 1 is clear. Basically I've counted that all the possible nodes within the k range. Next is, they have said that we can bridge from one current node that we are targeting. Let us assume that we were targeting 0. So I have 5 internal nodes that are target, but I now have to add one more part to it. So I can add a part either to 0 to 0, 0 to 2, 0 to 7, 0 to 1, any I can add. But I need to add with such a node that will maximize my final outcome, because for every node what I have to do is basically I have to tell the maximum possible number of target nodes to I. So what I'll do is I will target to place it to a node that has adjacent maximum nodes. Why so? Because that is what we need. If it has maximum number, let us assume I'm placing it with 7. 7 has only 2 connected nodes. Whereas if I connect it to 2, it has got 2 connected nodes directly to it. If I'm connected to 0, it has 2, 3, and 1. So that will maximize my number of chances that this will be the maximum one. So that is the one case to consider. So what I'm trying to do is, what I'll do is within the tree 2, I will try to do the same thing that I did with the tree 1, but now I will try to do the same thing with k minus 1. Why so? Because I will add a bridge, sorry, not bridge, an edge between the node from which I'm looking to the node I wanted. So one will be lost there. So I have to now figure it out the maximum nodes that can be traversed with k minus 1 distance. So that is what I will do here. So I will start from 0. So let us see, k minus 1 is will become 2 minus 1, that is 1. So basically I want maximum number of adjacent. So 0 has 1, 2 and 3 and 1 itself. So 0, 1, 2, 3. Similarly for 1 I will be having 0, 1 and 4. For 2 I will be having 2 will be 0, 2 and 7. For 3 it will be 0 and 3 itself, no more than that. For 4 I have 1, 4, 5 and 6 at one distance, unit distance, and that node will be included itself also. And rest if we'll see, for 5 I will be having only 4 and 5. For 6 I will have only 4 and 6. For 7 I'll have 2 and 7. So what gives the maximum? Maximum is 0 or either 4. Any of them we can take. And if we connect both of them, whatever the values that I was getting from tree 2 for a particular node, that plus whatever the value I got from the tree 1, that will be my answer. So let us assume I took 0. So this is my target node that I will be targeting every time I will go and target bridge. From 1 to I will add an edge to 0. If I'm on 0th index, I will add a edge between 0, 0. If I'm on 2, I will add it to 0. What this will do is this, I have 4 possible answers. So in that, initially for 0 I had 5 target nodes. 4 plus 5 is 9. And if you see the example, that is what is our answer for the very first element. If we go for 1, 1 has 3 and target was coming 4. 3 plus 4 is 7. That is what our answer is. Similarly, for 2, it is 5 plus 4, that will be 9. That we are getting again 9. And for 3 and 4, that has 4 elements each. Another 4 from here, and that my answer will be 8. So yeah, that is all basically what we have to implement it now. I hope that is clear. If you have any query, do comment it out. Now let's try to implement this. So first I'm going for a create graph, because we have given edges, we don't have a graph adjacency list, we have to prepare it. So for that I've created a create graph function, because they were basically that would be repeat twice times, that is why. So this is how I'm constructing it. For the sake, it was given that edges dot size, that will be the original size, but I tried here by taking the maximum that can be removed. Now what I have is I will take the create the graph with the max node, that is the maximum element that I got in the individual nodes, that I created the graph with that particular number of rows. In every row I will map it to the values that it have, simply just how we create the graph. So similarly we'll create the graph for G1 and G2, that is basically tree 1 and T2 that we have. Now what we'll do, I will create a vector of tree 1. Tree 1 basically stores this value that we mentioned, that for every node what are the possible target nodes that can be done in given particular k. So this is a BFS node that I have created. So what BFS node is doing, first it is checking that if k is less than 0, because in the constraint, if we look, this is an edge case, that k can be 0 also. So for 0 it makes sense, but when it gets to k minus 1, because we have to calculate for tree 2, this will be k minus 1. So for k minus 1, so basically it's better to first we remove at the initial phase also, why to add all those stuff there. So this is a simple BFS traverser, maintaining a queue of pair. First will be the node, second one will be the distance, marking the visited node, initially pushing the whatever I value that is coming from the for loop, and 0 is the distance, marking visited, and CTR is basically the counter, how many nodes are there, initially initializing it with 1, because 1 will be target with itself only, because any node is target to itself. Started the while loop. In the while loop, taking the first and second element, first will be the node, second will be distance, popping the top element, then iterating over g of node, taking if my visited of j is 0 and distance plus 1 is less than equal to k, then only add it. If it's greater than k, no need to add, and push that to q and continue, and finally return the CTR. And this will store for every I value the BFS node. So tree I will basically store 4 3 4 sorry 5 3 5 4 and 4 that will be stored in tree of 5. Next, what I'll do is I want a target node. Similarly to what I did, my target node will be basically the counter representing the maximum, that is target of 4, that should return maximum value is 4. So for every node I'm iterating back looking for the BFS node that it was calculated in the previous part. So this is how I will get the maximum target node. I basically want a maximum counter. That was I'm not storing it in the previous graph when I stored it because I wanted to return for every index. Here I just want the maximum one, and simply I will add that target node whatever the counter I got in every index of tree 1 and simply return that tree 1 vector. So that is all we have to do in this problem. So yeah, that was all. The time complexity will be n cross m because n will be number of nodes and m will be if m are the edges. For BFS traversal it will take, so that is why it will be under the limits because it is 1000, so 1000 to 1000 it will pass in second, but the second part of this problem won't pass that. There will have to optimize it. So this is solely concerned with question 3 of Leetcode. Yeah, so that is all in this problem. If any query, do comment it out. If you like the video, hit the like button and do subscribe for more daily content. Thank you.